Welcome to Measurement Module 6, Lesson 5, Solving Word Problems Involving Composite Figures. Calculators are allowed for this class. Now that you understand the basics of how to find the area and perimeter of composite figures, it's time to try some slightly more complicated problems that you may come across. Remember, the more you practice, the easier it gets. Objectives of this class. Objective number 1, find the area and perimeter of composite shapes with overlapping. 2, solving word problems involving the area and perimeter of composite shapes. Let's get to work. Question 1, students, look at the diagram on the right carefully. Find the area and perimeter of the following figure, not drawn to scale, where the overlapping portion, the one in dots, okay, the dotted area, the overlapping portion is a square of area 49 centimeters squared. Now, step 1, the first thing we've got to do is find the dimensions of the overlapping square. They've given us the area, and you know it's a square, so the dimensions are going to be same on both sides. So you take the square root of 49. And you and I both know that the answer is 7. But when you do it on the calculator, it's going to be the square root button, then you punch in 4 and 9, and then you hit the equal button, and you get the same answer, which is 7 cm. Right? Is 7 cm. So let's fill that information into the dotted area. That's 7 cm. And on the other side is also 7 cm. If you notice, there are two other information. There are two more information that is missing. So let's fill that up as well. Okay, that information. See, you follow the blue line over there. That information is missing, and the other one is on the that information is also missing. So how do you calculate that? You calculate that by taking 15 cm, and you minus off 7 cm, and then you get 8 cm over there. For the other side is going to be 14 cm, and you minus 7 cm, and then you get 7 cm over there. So you've got all the information you need to solve this problem. Now, step 2, we can now find the dimensions of the triangle and also the area of the figure. Now, I believe in verbalizing certain things. In this particular case, if you can verbalize the equation, I think you will really do well. So area of the figure. Area of figure is going to be the area of the rectangle plus the area of the triangle minus the overlapping area. You see that? You take the area of the rectangle, you add it on to the area of triangle, and then you minus off the overlapping area, and you will get the area of the figure. Right? So let's plug in the numbers. You get 15 times 14, which is the area of the rectangle. 15 times 14. And you add that to the area of triangle, which is half times base times height. Half times 22 times 15. And then you minus 49, which that information is given. That is the overlapping area. And then you get 210 plus 165 minus 49. And you get the answer, which is 326 centimeters squared. That is the area of the figure. Well done. Moving on to step 3, you're going to look for the perimeter right now. You're calculating the perimeter. You've got all the information you need. Remember, it is only the outlines, no internal lines. So let's look at it. You start there, you go around it. That's the perimeter, no internal lines. You see that? Okay, so let's plug in the figures. You start off with 15 plus 7 plus 15 plus 25, plus 8, plus 8, plus 14. And the answer you get when you add all of them up is 92 centimeters. That is the perimeter of the figure. That is your final answer as far as the perimeter is concerned. The area, as you have already calculated, is 326 cm squared. Well done. All right, students, question 2. The figure is made up of a quadrant. Follow the red light on the diagram. A quadrant, a rectangle, and a semicircle. A semicircle. Given that the perimeter of the rectangle, that means this perimeter, given the perimeter of the rectangle is 74 centimeters, find the perimeter of the figure take pi to be 22 over 7. So what is step 1? Step 1 is to find out the length of the rectangle. We want to find the length of the rectangle, which is the same as the radius of the quadrant. Do you realize that? Do you see that? This length is the radius of the quadrant. And the length of the rectangle is also the diameter of the semicircle. Okay, now let's go on to find how would we calculate the length of the rectangle. So you realize that the perimeter given to you is 74, right? 74. This is 9 cm, which means this is 9 cm, but there's another way to do it. You take 74 and you divide it by 2, which means you have half of the perimeter, and then you minus off this 9 cm, you should get the length. So let's do that. Let's write it down. Let's write it down. Length of rectangle. Length of rectangle is equals to 74 divided by 2 minus 9, which is equals to 37 minus 9, which is equals to 28 centimeters, and that's your length of the rectangle. Now, to find the perimeter of the figure, remember to add up all the sides that make up the outline. Now, let's do this. Perimeter of the figure equals to arc of the quadrant. Okay, you have to calculate the arc of the quadrant plus the semicircle. The arc of semicircle, this is the arc of the semicircle, plus 28. How is this 28? Because this is the radius, remember? 28, this is the radius, which means this is 28 cm as well. And this is 9, and this is 9. So you add all these figures together to get the perimeter of the figure. So let's write it down. Perimeter of figure. Let's set up the formula. Arc of quadrant. A full circle is 2 pi r, right? So an arc of the quadrant would be 1/4 of 2 pi r times 2 times 22 over 7 times 28, plus, put that into a bracket, okay, plus arc of semicircle is going to be half. So it's going to be pi d. 2 pi r and pi d is the same thing, right? So it's pi d half times pi d, 22 over 7 times 28. Okay, that is for the semicircle, plus 28 plus 9 plus 9. When you do the mathematics behind it, you get 44 plus 44 plus 28 plus 9 plus 9. Add it all together, you get 134 centimeters, and that is your final answer. That is the perimeter of the figure. You've done well. Let's move on to question 3. Alright students, last question of this lesson. The following figure is made up of 3 identical rectangles. Keyword, identical. Given that the perimeter of the whole figure is 40 cm, that means the whole figure, the perimeter is 40 cm, find the area of each small rectangle. Find the area of each small rectangle. Now, once again, we've got to figure out the relationship here. Look at the diagram, see if you can see a relationship. Now, how would you calculate this? Do you realize that this one length is equal to 2 breadth of a rectangle? Okay, let me repeat that. One length, the length of the rectangle equals 2 breadth of the rectangle. Do we see that relationship? So basically, if we are going to set up a ratio, we can say that the length to breadth ratio of the rectangle. So the ratio is what? Length to breadth ratio is 2 is to 1, right? 2 breadth is to 1 length. So let's write down the units around the rectangle, shall we? Okay, 2 units, 1 unit, 2 units. Do you see the relationship? 1 unit, 1 unit, 2 units, 1 unit. Now when you add up all the units, you'll realize that all the units added up together will give you 40 cm, which is the perimeter. So when we add up all the units, what do we get? 1 plus 2, 3 plus 1, 5, 10 units. 10 units equals to 40 centimeters. Therefore, 1 unit is equals to 40 divided by 10, which is 4 cm. So 1 unit is also the breadth, right? 1 unit is also the breadth. 2 units, which is equivalent to the length. 2 units, which is the length, is 4 times 2, which is 8 cm. Okay, and one rectangle is made up of what? 2 units as length and 1 unit as breadth. So area of rectangle, which is the last step for this problem, is going to be what? 8 times 4. What's the answer you get? 32 centimeters squared. And that is your final answer, and we are done with this lesson. Alright students, I will see you again in lesson 6. We are done with this one. Attempt the quiz. Remember to visualize, get creative, ace the quiz, and go score.